Hi everyone. So the question that I'm going to solve today is integer break. So what does this question states? That we are given an integer. For example, we are given an integer n equal to 10. So what do we have to do? We have to break this integer into two or more parts in such a manner such that their sum is equal to 10 itself. For example, in how many ways can we break a 10? Uh, 10 into two or more than two parts. Some of the ways are like we can say 2 plus 4 plus 4. This is has sum equal to 10, or we can say 3 plus 6 plus 1. So there are many other ways. So what do we have to do? We have to break it in such a manner that the multiplication of the numbers is as high as possible. For example, in this case, the multiplication is 4 into 4 16 into 2 32 32, and in this case 3 into 6 is 18, and 18 into 1 is 18 itself. So in this case 18. Other ways are like 5 and 5. So in this way, the multiplication is the answer is 25. So there can be many ways like 1 1 1 10 times, which will give answer as 1. So what do we have to do? We have to break the number into such a manner, break the number in such a manner such that the all the numbers when multiplied give the result as high as possible, and we have to return that result. In this case, when we see these examples, these four examples for 10, the maximum number is 32. There might be some better answer for this, but I'm just showing for example that we have to return this number which is as high as possible. So this is the problem. So how do we approach such a problem? Here let's say the number is the n that is given to us is 10. So there can be many ways of partitioning this, like I said before. So we don't know that which way will give the most optimal answer. So when we have such a problem, we have to find every possible way like 2, 5 and 3 and many other ways. So we will have to check for every possible way. How do we do this? Obviously using recursion. So how will we apply recursion in this problem? So what can we do? Like we can start breaking the number, like if we break the first part into 1, and uh, then the remaining number is 9. So we can call a recursion function which will find the best possible answer for 9. If we break the first part into 2, then the remaining number is 8, and we can call a recursion function to find the best answer for 8. Similarly, we will do this till 9. Obviously we can't keep the first part as 10 because the remaining part will be 0, which is not allowed. So we will do this till 9. When we break the first part into 9, then we have remaining number as 1, like this. So and this what will this recursion function do? Like we have the current number is 9, we can break this, for example, the first number into 2 into 3, and then this will find the best answer for 6. Then what will this function do? This can break, for example, this will check for till 1 to 6, like this will check for 1 till 9. I have shown for 3. Similarly, when we call for f and the uh, number is equal to 6, then what will happen? Let's say if it breaks the first number into 2, the first part is 2, and then it will find the best answer for 4. Similarly, this thing will keep on happening until it reaches the base case, so which will start and then which will return from here, and after that this will return from here, and the best answer will be stored, that the answer for 1 will be stored in a variable called answer. Then similarly, in this variable only, the maximum out of the maximum answer out of for 1 and 2 will be stored in this answer variable. Similarly for 3 and for 4 till 9, and then I will return this answer variable. I hope you got the point. So one more optimization can be done here. If you observe that, let's say if we have n equal to 10, one thing here to observe is that when we are calculating for 2, then the function is returning the best answer for 8, like I showed before. So when we will do this for 3, the function will return the best answer for 7. Similarly, when we do this for 4, the function will return the answer for 6. And when we do this for 5, then the function will return the answer for 5. So here will be 4. So so tell me one thing, that do we have to find for 6, in which case the function will return for 4? Actually, we don't have to find after 5, because 6 into 4, 6 into the best of 4 has already been calculated here. So we don't have to find for this. Similarly, for 7 and f3, we don't have to find, because it has already been calculated here. So we don't have to do it here again. Similarly, for 8 into 2, we don't have to do, and for 9 into 1, we don't have to do again. So in this way, we just have to traverse from 2 till the half of the number, and we have to find the best answer for every number in between that. I hope you got the point. I will show you the code so that the things become more clear. Here I have coded in Java. So here we are given an integer n. So what am I saying? That if the number is equal to 2 or the number is equal to 3, I'll return directly n by 1. Why? Because when we have n equal to 2, there is only one way of breaking the number into 2 or more parts, that is 1 plus 1. There is no other way. And when we multiply 1 by 1, the answer is 1 itself. Okay. Similarly, if we have n equal to 3, there is only one way of breaking 3 into 2 or more than 2 parts, that is the first part is 2 and second part is 1, or the first part is 1 and second part is 2, both are same things. So when we multiply these, the answer is 2. So that's why I'm doing this, that when I have n equal to 2 or n equal to 3, I'll directly return n minus 1, because the answer for 2 is 1 and the answer for 3 is 2. Okay. So now here I am declaring a dp vector of size n plus 1, because if we do not apply dp, it will give time limit exceeded. So, and now what am I doing? That I am storing initially every index of the dp vector as -1. So now I have called my function which will calculate the answer for me. So here is the function. First is the n, and the next is the dp vector. So first ignore this base case. I'll tell about this later. So what am I saying? That if the current index of the dp is not storing -1, return uh, the current index of the dp, because so that we don't have to calculate it again. And initially I'm storing the answer as -1. And now what am I doing? That starting from 2 till half of the n, because we don't have to find after n by 2, and we don't have to check for 1 again, because 1 will give, we can, although we can do this, but this is not required, because when we multiply 1 by any number, the answer is the number itself. So we don't have to calculate for the 1, this will be redundant. So now what am I saying? That int best answer possible. So if I am keeping the first number as I, so what is the best answer possible for n minus I? I will find this using this function. And then what am I saying? That answer will store the maximum of the current answer, or the I times the best possible answer for the complement of I. For example, here if I is 2, then this function will calculate the best answer for 8 when n is 10. Okay, so this thing will happen For every number, for example, if n is 3, this will calculate the best answer for 7. If n is 4, this will calculate the best answer for 6, and same thing will happen. And when we call this function with n equal to 6, this will find this will keep this will start with like the current number as 2 and find the best answer for 4, because here n is 6. So in this way recursion will work like this here. And here also we will keep n as 2, the I as 2, and find the best answer for 2 again, and same thing will happen. So, and now the base case is if n is 2 or n is 3, like I showed here, because the best answer for 2 is 1 and the best answer for 3 is 2. So what am I saying? So we don't have to calculate again. So what am I saying? If n is 2, we don't have to search for any answer for this, because when we multiply 2 by any number, it will give 2, and we don't have to break it into 1 and 1 because it will give 1. So the best answer for 2 is 2. And when we have 3, we don't have to break it into two parts, like because the two parts will be 2 and 1. So 2 and 1, which will give 2. So the better idea would be to directly multiply 3, because it will give more value. So in this way, when so in while returning, I am also storing the answer in dp of n, and this will work. So it is fine. If you have any doubt, you can ask me in the comments. Thank you.